In addition to his academic responsibilities, Dr. Nandan presently looks after other administrative positions at the institution level. He takes keen interest in efforts directed towards environmental sustenance. Well, we welcome you, sir. Please.
Thank you so much, Shikha, and thank you, Lokesh. Good evening, everyone. As mentioned, I am Tanuj Nandan, and I just want a quick feedback. And is my screen visible? Is my presentation visible on the screen?
Yes, sir.
Right. Thank you so much. So, we are talking about sustainability, and today I'll just touch upon the topic of circular business models. It's a very interesting concept, and we are adapting to it over a period of time. We are moving over from linear business models to circular business models. So, let me just start. But before I start, if the participants have the permission to unmute themselves, I'll just like to request that please feel free to add whatever you want to interrupt me. I don't feel disturbed at all. So if anyone, because I know all of us are academicians here, everyone would have their own perspective, their own experiences. So if anyone has anything to share or to add to what I'm saying, please feel free to interrupt me in between. And also, if there's a problem in understanding what I'm saying, maybe someone wants me to speak in Hindi or someone wants me to speak in English, please let me know. Okay? So let's start. This time permitting, this is what I intend to cover today. The agenda is, firstly, we'll talk about what are circular business models. Then we'll talk about the basic principles of a circular economy. We will look at certain strategies which are important for circularity, for sustainability. And these are 10 strategies which have been formulated, which are currently in use, numbered from 0 to 9. So we call them, because all of them start with the alphabet R, so they are known as R0, R1, R2, etc. So these are the 10 strategies that we'll be looking at. We will have a look at some innovative business models which are very much right now in vogue. They are in use. So people have already innovated. They have put into position these business models, and these business models are aimed towards sustainable living. So we will have a look at some of those just as examples. Then we will look at uh, three things: biogas production, biomass production, the trends in that, how is it being used today, has it traditionally been used, and then we'll look at this aspect of biofuels. So I think we have something like 85 minutes now, and then permitting some time for interaction and your questions. I'll try to wind up, let's say, in 75 minutes, and I think I will be able to cover this entire um, 7 or 8 points in this period of time. Okay, let's move forward. So, firstly, what are circular business models? Now, in order to understand what circularity is, first we need to understand what linear business models are like. In a linear business model, and this is the way we have traditionally been conducting business, we take materials from the earth. So we use the earth, we exploit it for raw materials. We take those raw materials, we convert them into finished goods, we make products out of them. And at the end of the life of those products, or when they are no longer required, we throw them away as waste. So it's a linear process because we are taking raw material, using them, and then throwing them away. A circular process would involve, you take the product close to the end of its life, and then you try to bring it back into the cycle of usage. If we are able to do that, then the overall process becomes circular. But right now, our business models, the way conventionally we have been doing business, is very much linear. So, needless to say, this process is wasteful, it is harmful to our environment, and when we're talking about sustainability, then this is definitely not sustainable. We already know we have exceeded all limits of how much we can exploit the earth. The effects of that are visible. Our land masses are badly polluted, our oceans are badly polluted, the air is polluted. We are talking about AQI all the time. So it is harmful, and it is really, if you want to continue to exist with quality of life on earth, then this is no longer the way that we can do business. And that is why we are moving from linearity to circularity. We should have done it much earlier, but we are beginning to do this now. So we talk about the development of a circular economy, and those of you who are familiar with this area would agree that circular economy is now something which is very much in vogue. So we are constantly discussing, deliberating, researching what the circular economy should be like. So the development of the circular economy for products is being encouraged because we want to reduce waste and we want to conserve precious resources. And like I mentioned, that we are at the initial stages of this, so development is still limited. This process needs to be given impetus, and which is why training programs, faculty development programs, discussion forums like these are important, so that we can get together, have a look at why they are needed, and then try to come up with solutions for these. Also, we need to tell our scholars, we need to tell our students about the importance of circularity, the circular economy. So business as usual has involved has been like since the industrial revolution, which we now refer to as industrial revolution 1.0, because we are talking about 2.0, 3.0, 4.0, and now even 5.0. So what we refer to as industrial revolution 1.0 is the point of time when James Watt invented the steam engine. So coincidentally, because it allowed work to be done by machines rather than animals or humans, therefore we treat the beginning of the first industrial revolution as the invention of the steam engine. And just, I mean, it would really be interesting to see how that industrial revolution has changed our environment for us. So what I have done is I've just put some slides together to try to depict what has happened in the world after Industrial Revolution 1. It's just a timeline, and why it is alarming. Why are we talking about circularity at all? But before we do that, I'll just show you a very small video, and I will pause it in between just to get some feedback from the participants whether the audio is going through or not.
Very well said.
Many of the things we need come from nature. A precious metal.
No, I meant the. Can you hear the audio of this this video right now?
Yes, sir. Yes, sir.
Okay, fine. Thank you so much. So then I'll continue.
Many of the things we need come from nature. A precious metal like gold is mined from the earth. Then it is taken to a factory where it might end up in a phone. The phone is used until a new phone comes out and the old one is thrown away. But where does it go? Either it goes to landfill or it is burned. There are three stages: take, make, and waste. And we have been doing this for over 200 years, ever since we were able to mass produce things in factories. The trouble is, we don't have an endless supply of materials such as gold that we can use up and throw away. And we can't keep harming the planet with all the waste and pollution that we create. This planet is our only home. So what could we do differently? What if we repaired the phone when it broke? What if we reused it when we no longer wanted it? What if we remade it when it was no longer repairable? What if we recycled the gold and other materials inside so that they could be used to make brand new phones? The phone could live, then die, then its parts could give life to a new phone. A cycle inspired by nature. In nature, waste is always used to make something else, again and again. Now let's take an orange. The orange grows and is harvested by a farmer. The orange is taken to a store where somebody buys it. That person eats the orange and throws away the peel. Like the materials inside the phone, the nutrients inside the peel are lost. So what could we do differently? Did you know that orange peel can be turned into fiber that can be used to make clothes? What if we turned the peel into a gas to produce energy? What if we composted the peel and returned the nutrients to farmland to grow more oranges? By keeping products and materials in these cycles, we could create a system that puts back more than it takes and nothing is wasted, allowing the earth to regenerate while giving us the things we need to live. Finally, imagine all of this was powered by renewable energy. It is called the circular economy, and it is happening right now. But this isn't just about mobile phones and oranges. Look around you. Imagine if everything was designed from the beginning to fit in these cycles. There would be no such thing as waste or pollution, so nature and wildlife could thrive. When we see the world as a blank canvas, the possibilities are endless.
Right. So this, I actually added this small video because I wanted to bring out just the idea of what we have been doing and why it is important to stop doing things in that linear fashion and move to the circular way of doing business. So the circular economy. Now, with this background, let us just move forward and have a look at the very clearly measurable effects of what we have been doing. So, like even in this video, it was mentioned that after the invention of the steam engine, which is Industrial Revolution 1.0, it became possible to mass produce. So earlier the production used to be limited, so the exploitation of resources was also limited. But the invention of the steam engine, it set into motion a series of further developments that made mass production possible, and therefore our rates of development have grown phenomenally across parameters. So I brought these slides from a particular research by Broadgate et al., a 2015 research, and they have covered this period of 260 years starting 1750, which is roughly the beginning of the Industrial Revolution, till 2010. Let's have a look at it. Now, if you just look at this timeline, 1750 to 2010, there are some 12 parameters which are given here. Some of them are really good, but you just have a look at this vertical line which has been drawn in terms of what happened after 1950. And those of us, I mean, all of us understand growth rates, all of us understand curves, and we can see that there has been an exponential growth in several parameters such as GDP, such as use of water, such as the use of energy, use of fertilizers, telecommunications, the number of dams, overall population, percentage of the population that is, or the number of people who are in urban areas, all of this. Now, all of these are not bad. I'm not saying that these are bad. These are just parameters. So these are socio-economic trends. But if we then try to correlate these trends with what we have been doing with the environment, so the fallout of all of these things like the increase of population or too many dams or use of energy or use of water or use of transportation, just let's try to have a look at what it does to our environment. So we have now 12 parameters here which talk about some gases such as carbon dioxide, nitrous oxide, methane, the ozone in the stratosphere, which has been lost actually, the surface temperatures, how many fish are being captured, how much shrimp is being produced, how much forest has been lost, how much land has been domesticated, and so on. The biosphere degradation, you can also see that there is a 1:1 link between the growth in population, the growth in our economies, and the growth in these parameters. And the top three, which is given here, carbon dioxide, nitrous oxide, and methane, these happen to be the top three greenhouse gases. And for the rest of it also, you know that these are all indicators that our environment is suffering. So there is a link between what we have been doing socioeconomically and what has been happening to the earth. And therefore, I don't think I need to stress this point any further. The case is very well made out that we need to rethink and we need to revisit what we have been doing, and which is why the need for programs like this, the one that you're attending, the need for sessions like this, which is on sustainability. I'll just add one more slide and then we'll move on. Now, in the same aspect, if we look at what is happening, if we break it down into the more developed countries, the developing countries, and the rest of the world, again, you can see that there is a distinction, but I will not dwell upon this too much. Let's just move forward from here. So let's move to the concept of a circular economy. Now, what happens in a circular economy is that we are trying to take value out of resources which are already in use. So it is based upon the generation of value by decoupling of economic activity from consumption of finite resources. On one hand, we have resources which are finite, and in a linear economy, our economy will keep on growing as long as we are exploiting these resources. But in a circular economy, we are breaking that link, which means that economic development does not have to be dependent upon the use of resources which are finite in nature. This is the basic concept of a circular economy. And it is based upon three principles. The first is we need to eliminate waste and pollution. I think you go to any major city, unfortunately in India, particularly you go to NCR, Delhi. Anyone in this session who is from that area, NCR, Haryana? Do we have any participant here? You drive out of Delhi towards north, the Singhu border side, when you're moving towards Sonipat, Panipat and onwards. As you're exiting Delhi, you will find there's a huge mountain, and that is a mountain of garbage. You drive towards Gurgaon, you will find that same thing, on which the large bulldozers, they look like this, small toys. So we know that we are generating waste, not just, this is an example of solid waste, but all sorts of wastes at an alarming level. We need to eliminate the production of that waste and pollution. This is the first principle of circular economy. The second thing is we need to circulate products and materials, which means that we need to keep on using them in a circular manner. And there is the concept of value here, which I will be discussing slightly later. We need to do this so that maximum of the value present in those resources is retained. So when I say at the highest value, it means that when we are recycling, we should be able to derive the maximum value out of those resources, even when we are reusing them. And the third thing is we have done a lot of damage to nature. We need to regenerate nature. So once again, eliminate the production of waste and pollution, bring in a circular mindset where we are using products in a circular fashion, and regenerate nature. These are the three basic principles that underlie the concept of a circular economy. And if we add to this renewable energy and renewable materials, then it makes the circular economy resilient, which means that it can continue to sustain itself. And this is good for the business, it is good for people, and it is good for our environment as well. So it is a win-win-win situation, which is why circularity is important, and which is also why when we talk about renewable energy and materials, I have added a little bit about biogas, biomass, biofuels, etc. So we'll come to that slightly later. Now, the transition from linear to circular, this is very important. Probably in this entire discussion, 80-minute discussion today, the most important is how do we transit from a linear business model to a circular business model. So we will have a look at these strategies, which are, as you can see, R0 to R9, these 10 strategies. Now, this is divided into rows. So at the top row, we have the type of the economy. Left to right, we are moving from linear to circular economy, which means as we are moving towards the right, the business strategy that is associated with this, which means the strategy R9, R8, R7, R6, these are becoming more and more towards circular business models. So the phase of life in a linear economy, any phase of life, the same thing will apply. But R9 and R8 strategies are used for end of life products, which means products which are reaching the end of their useful lives. R7 all the way down to R3 strategies are used at the consumption phase, and R2, R1 and R0 are applied at the design phase. In terms of value, remember that we are trying to retain as much value as possible. In a linear economy, value is lost. In R8 and R9 strategies, value can be captured and it can be retained. In R3 to R7 strategies, value can be optimized, but in R0, R1 and R2 strategies, value can actually be added. We can enhance value. So which means that the strategies that we should, or the business models that we should be aiming for, should be towards the design part. So the lower level is better than the higher level of Rs, which means R0 is better than R1, R1 is better than R2, and so on. Now we will talk about these, we'll spend some 15-20 minutes talking about these strategies, and we will also see the outcome of this. So let's start first from R0. And these strategies are R0, R1 and R2 have to be applied when we are designing a product or a process. If the product or process is such that it is already in use, then it becomes difficult to apply R0, R1 and R2, and then we have to move to R3, R4 and so on. But if we want to add maximum value to our resources, then we have to think of these strategies at the design phase. So which is why it is important to look at design. Now, it's not always possible to look at designs. For example, there are millions of automobiles which are in use today, and they have not really been designed to fit the circular economy. So if I am using a 15-year-old car, it has already been designed maybe 18-20 years ago. So maybe R0, R1 and R2 strategies may not be applicable there. The other strategies, R3 and R3 to R7 strategies, would be applicable there. Let me give you an example of R0. So R0 strategies, which are supposed to be the best, R0 stands for refuse. We have all heard of refuse, reuse, recycle, reuse. So 3 Rs, 4 Rs, but now we are talking about 10 Rs. R0 refuse strategy at the individual level, would any one of the... हाँ यशवंत जी प्लीज, यशवंत हरने जी आपने हाथ उठाया हुआ है. So
मैं पहले उठाया था सर, अभी
जी
आ
बताइए
गए आप.
बताइए. हाँ एक्चुअली मेरे स्क्रीन पे ना दिखता नहीं है, unless I switch between presentation mode and this mode, I cannot see who has raised a hand. So please
मैं
अभी
इतना पूछना चाहता था
जी जी पूछिए.
कि ये जो ट्रांजिशन है वो बहुत लॉन्ग टर्म होता है क्या? तो आप अभी आ रहा है उसमें?
हाँ, सो जैसे जैसे हम आगे बढ़ेंगे मेरे ख्याल से इस सवाल का जवाब मिलना चाहिए. नहीं मिलेगा तो फिर हम इसको डिस्कस करेंगे.
Okay, sir.
Right. Okay. My question was, can anyone give an example of a refuse strategy?
So may I?
Yes, please. Yes, Vaishali.
Yes, sir. If we go to the like to buy something, groceries, vegetable markets, etc., and we get a polythene bag. But
Yes.
if we refuse that, okay, I have my own cloth bag, or I'll be comfortable carrying in my hands or whatever. But when we
Perfect.
refuse it, that time,
Perfect.
so maybe it is.
So the strategy is simply say no to plastics, है ना? बहुत simple है. Plastic का प्रयोग नहीं. And you go to so many places, you will find that the use of plastics is not allowed. Ideally, it should not be allowed. At least single-use plastic should not be allowed anywhere. So that's a very good example of refuse at the individual level. I will tell you, मेरे institute में क्या होता था, when Lokesh sir had asked me to share my profile, I did not share much. मैंने 3-4 lines share किए, पर एक last में line डाला कि I take a lot of interest in efforts aimed towards sustainability. So जब स्वच्छ भारत अभियान इंडिया में लॉन्च हुआ था, तो I was made in charge of स्वच्छ भारत अभियान for my institute. And we have it's a large institute, we have a large number of students, and what used to happen at that point of time was that, for example, in our examinations we used to serve students water in sealed packaged glasses. So I think 250 ml glasses, plastic glasses, ऊपर से सील होते हैं. अब वो जो ग्लास आते थे, वो ग्लासेस एसेंशियली प्लास्टिक के होते हैं. एक शिफ्ट में करीब 3,500 ग्लासेस ऑन एवरेज, सॉरी 3,500 स्टूडेंट्स बैठते हैं ऑन एवरेज. हम ये मान लें गर्मी के दिनों में, और यहाँ पे तो 9 महीने साल में गर्मी रहती है, एक शिफ्ट में करीब 8-9 हज़ार ग्लास वेस्ट होते थे, प्लास्टिक वेस्ट होती थी, और 12-15 शिफ्ट्स का एग्जाम होता है. सो यू कैन अंडरस्टैंड कि करीब 1.5 लाख वेस्ट प्लास्टिक ग्लासेस सिर्फ एग्जाम की वजह से जनरेट होते थे. तो when I was given the charge of Swachh Bharat Abhiyan, what I did was, I said, why can we not use the kind of paper glasses that you will see in malls or airports or so many places, which don't even have any kind of printing on them, so there's no dye which has been used, and those are recyclable. So what we did was, we ordered 10-liter cans of RO water from a supplier, and in every classroom we started putting those paper glasses, and we removed the plastic glasses. And what we did was, we put an appeal to the students in the examination schedule. First page there used to be an appeal that if possible please carry your own water. And we also put one more appeal, and we did this with our stores also, because we have it's a residential campus, so every hostel has a store, which is a shop, that you start selling metal bottles also. So we made metal bottles available to them at subsidized prices. We told all the students कि please जहाँ तक हो सके आप अपनी बॉटल लेके आइए, उसमें भी बहुत अच्छा होगा प्लास्टिक की जगह अगर आप मेटल की बॉटल लेंगे. और हमने एक चीज़ और की, हमारे यहाँ क्योंकि रेजिडेंशियल कैंपस है, स्टूडेंट्स को पीने का पानी चाहिए रहता है, तो हम और हमारे यहाँ जो RO सिस्टम्स हैं, जो पानी प्योरिफिकेशन सिस्टम्स हैं, वो टेस्ट होते हैं, तो हमने सब पे स्टिकर लगा दिया कि किस दिन ये चेक हुआ है और कब तक ये वैलिड है, मतलब इसका पानी पीने के लिए सेफ है कि नहीं. सो naturally students have a lot of confidence when they are filling water from that. So over a period of 2 or 3 years, what happened was, now if you go to the exam hall, you will find that almost every student is carrying their own bottle. So this is a very good example of refuse. Like Vaishali ji said, say no to plastics at an individual level. At a corporate or business level, what can be a refuse strategy? Now, for example, when internal combustion engines were designed initially, they used to have a particular problem. The problem was referred to as knocking. There was a problem with these engines that they used to have a phenomenon called knocking. And in order to reduce knocking, it was found अगर पेट्रोल में और डीजल में थोड़ा सा परसेंटेज lead का मिला दिया जाए in a particular form, then that problem of knocking is solved. So for about 80-90 years Even now, lead is added to certain fuels, but for 80-90 years, it was added to all the petrol that we consumed, all the diesel that we consumed. And that was harmful because lead itself is toxic. So people who were working in the refinery, people who were working at fuel stations, people who were using that fuel, and the emission of that fuel used to have lead content in it, which was bad for the environment. So what they did was they redesigned the way engines are built, so that those engines could still function but without adding lead. So they said we will no longer add lead, and now we have unleaded petrol available at all our fuel stations. Even in some parts of the world, even now they are adding lead to their fuel, but that has gone down. So that's a very good example of refuse. Let us move to the next strategy. Rethink. Rethink means that, do I really need this component? It could be that, like, for example, in Europe, this is very common. Their automobiles are much smaller than the automobiles that we have in the US or many other parts of the world, for two reasons. Firstly, fuel is more expensive there. And secondly, in the urban areas, parking space is at a premium. So you will find that many of the cars are actually not four-door, but smaller, compact cars, which are two-door cars. We also need to think. So many of my friends are buying now 7-seater, 9-seater cars when they are currently in a family of 2 people. So we need to think whether we need that size of a resource or not. So that is rethink. Then we move to reduce. Reduce strategy means reduce the amount of a particular component. And this becomes possible, for example, in the airline industry. They are trying to reduce the weight of the metal used in the aircraft. You would also know that many aircraft like the Airbus A380 or even the 787 Boeing, these are now being made out of composite material. So they are reducing the amount of metal that is going into it. By reducing the amount of metal, they are reducing the dependence on metals, for one thing. Secondly, they are reducing the amount of fuel required to move that aircraft, because the heavier the aircraft, the more fuel you will consume. So that could be an example of reduce. Anyone would like to give an example of reduce? Any other example? See, like
I have one example, like in hospitality industry, like in 5-star and 7-star hotels, like they have this concept, sensor-based lighting system. So
Yes.
if in the toilet or in some area of the room you are not present, so it censored the unavailability of human being, and the lights get automatically their lights get switched off.
Very correct. Very correct. In fact, I am currently doing a major research project, funded research project on this. It is talking about the audit of energy being used in a building and monitoring of that using IoT, Internet of Things. And also it incorporates this particular aspect, sensor-based lighting systems. If you look typically at what is happening in a school, parents coming to drop their children, pick up their children, it happens right outside my institute where I'm sitting right now. There's a school. So many people from my institute will go and pick up this children from the school. Everyone is going in a large car, one person driving a car and bringing one child. What happens if we do carpooling? So you're reducing the number of vehicles required for the same purpose. So there could be so many examples. What Shikha just mentioned is a very good example. And you can understand why these are at the design stage, because you have to think about how you can incorporate them into a product or a process. That's why they are there at the design phase. Now, certain products which are already designed and already in use may not be amenable for R0, R1 and R2 strategies, in which case we come to the R3 to R7 strategies. So R3 the third R, or the fourth R, which is R3, stands for reuse. So, which is why I mentioned that single-use plastic should be banned. But if you can reuse that, it's not such a bad thing. So, reuse is R3, repair is R4, refurbish is R5, remanufacture is R6, repurpose is R7. And sequentially, they are getting to be more evolved strategies as we go down from R7 to R3. I'll give you some examples of these. Particularly in countries where they don't have as robust a manufacturing system as they have in India. Like even in India, we have a very good system where we go from reuse, repair, refurbish, remanufacture, and repurpose much better than the developed economies. Yet, because we still have very good manufacturing prowess, so we are becoming less dependent on these strategies. So many of us will buy a product, use it, and then throw it away. But in those countries where the manufacturing is not that robust, so for example, you might have seen so many videos from either from Africa or from countries like Pakistan. I'll give you the example of Pakistan specifically, where they have wonderful expertise in repairing, refurbishing, remanufacturing, reusing, and repurposing products. You would find that trucks which were manufactured maybe in 1950s are still being used there. Why? Because in any other country, they might actually have been discarded. But here what they do is they have developed amazing skills to repair them, to put them back to use. If they are beyond repair, they will remanufacture. I have seen them building entire engine blocks, axles, leaf springs, bodies, everything of automobiles, and so many other things. So they have that expertise. We have that expertise in India also, but we are becoming less and less dependent upon it. So those skills are dying out. In so many countries of Africa, the entire mobility of people is based upon buying cars which have been discarded in the developed world. So they will import those cars, and then they will use their amazing skills on those, and they will actually bring them back to life, use them for many more years. So that is an example of both reuse, repair. Similarly, refurbish. If you go out into the market to get a photocopy done, then हाँ यशवंत जी, ये आप देखिएगा, कभी भी आप देखिएगा, इफ यू जस्ट डू अ सर्च, सभी जगह आजकल छोटे छोटे वीडियोस पड़ रहते हैं, जैसे फेसबुक पे रील्स होती हैं, आप देखिए कि ऐसा एक्सेल जो ट्रक का है और जो टूट गया है और उसके बिना ट्रक चल ही नहीं सकती है, आप सोच नहीं सकते हैं कि वो कैसे ठीक होगा। और वहाँ पे मैकेनिक्स है जो उसको बिल्कुल ठीक कर लेंगे। जब इंजन ब्लॉक में नॉर्मली हमने देखा है, इंजन ब्लॉक इज बेसिकली द हार्ट ऑफ अ व्हीकल, उसी के बेसिस पे कार चलती है इंटरनल कंबशन इंजन में। उसको क्या करते हैं कि जब इंजन का जो सिलेंडर होता है वो घिस जाता है, तो उसमें दोबारा बोर करके थोड़ा सा बड़ा पिस्टन डाल देते हैं, उसका बोर थोड़ा बड़ा हो जाता है, फिर यूज कर लेते हैं, लेकिन कुछ टाइम के बाद वो यूजेबल नहीं रहता है। सो आई हैव सीन दैट दे टेक दोज यूज्ड द मेटल फ्रॉम दोज ब्लॉक्स, उसको मेटल को गला के दोबारा इंजन ब्लॉक कास्ट कर लेते हैं। आपका जो बड़ी बड़ी फैक्ट्रीज में इंजन ब्लॉक कास्ट हो रहा है, टाटा मोटर्स की फैक्ट्री में हो रहा है या फोर्ड मोटर्स की कंपनी में फैक्ट्री में हो रहा है, वो लोकल लेवल पे उसको कास्ट कर लेते हैं। आई डोंट नो इफ एनीवन हैज सीन दोस वीडियोस। Anyway, if you're interested, you can have a look at it. Now, I was talking about refurbish. You go to a roadside photocopy machine operator, you will find that typically a photocopy machine costs quite a lot of money. It's difficult for a small operator to invest that kind of money. So most of the machines that these people are using in the market are those which have been used by some big office or some setup. Then the company takes it back, the company will officially refurbish it, which means that it will change those components which are no longer usable. It will bring it back to a certain level of usability. It will certify it, and then it will sell it to these operators at a much lower cost than the original cost. You might have also seen that there is an active market for refurbished electronic items. आप अगर चाहें तो आप कोई अच्छा इलेक्ट्रॉनिक आइटम जैसे प्रिंटर, फोन आप ऑनलाइन खरीद सकते हैं. कंपनीज रिफर्बिश करके उसको सर्टिफाई करके रीसर्टिफाई करके दे देती है कि हमने देखा है और ये हमने इसको इस कंडीशन में ले आए हैं कि दोबारा यूज किया जा सकता है. सो यू माइट हैव सीन दोज काइंड्स ऑफ प्रोडक्ट्स बीइंग सोल्ड. इवन लाइक प्री ओन्ड कार्स का बिजनेस जो है बहुत अच्छा है. नाउ like Maruti Suzuki itself or Maruti itself, they have their true value, which means that if I, as an owner, I feel that my car is now getting old, I will give it back to them, but they will not sell it just as it is. They will bring it back to a state where it is perfectly good to use, which means that they will refurbish it and then they will sell it to a secondary buyer. So that is refurbish. Next strategy is remanufacture. Now, sometimes it might not be possible to refurbish. Then we go into remanufacture strategy. So, for example, like I said, that the metal or the engine block is so badly worn out that it has to be broken down and manufactured again. So, this is an example of a remanufacture strategy. And then we have repurpose. Repurpose means you use the same product but for a different purpose. So it is no longer usable for the purpose for which it was originally intended, but it can still be used for some other purpose. So if you repurpose it, at least it is not ending up as a waste. So repurpose means you take the same product, but use it for a different purpose. And there is an active market for this as well. So for example, diesel motors which are no longer usable for running a tractor or maybe a truck, because they do not have that kind of compression ability left, could still be used to make a generator set or a pump set. So there are many people who are doing this. So that is repurpose. Same product, but now being used for a purpose different from the originally intended purpose. That is repurpose. So these strategies are R3 to R7 are the consumption stage strategies at the stage of consumption. So which means that the end product of these can still be put to use. And please remember, जितना कम number होगा strategy का उतनी preferable है circularity के aspect में. So we ideally should prefer those strategies which have the lower R number. Then we come to two strategies, the 9th and the 10th strategy, which actually happen at the end of the life. End of the life means now whatever you have can no longer be used. So we have to take it and try to retain some value which is present in the resources. So in this we have recycle. I don't know if you're aware, but so much of glass is recycled. We can always keep on manufacturing fresh glass, but recycling of glass is always cheaper. So much of rubber is recycled. In fact, large trucks or large automobiles, their tires are always recycled. So much of metal is recycled, metal scrap. So recycle. And another strategy is recover. I'll just take 2 minutes to talk about recover also. In recover, what is happening is we are taking out from a used product, we are taking out those components which have value, but we are discarding those components which do not have value. For example, today electronic waste is a major headache. In any office, you will find, even in any home, you will find a lot of electronic waste. In my home, I could have more than one printer lying around, out of which I don't use one. I don't even need one. So that is a waste for me. I will have a stereo system. I will have so many old phones, landline and mobile phones. All of us can relate with that. Same thing happens in our offices. In this office also, we have so many computers, so many photocopy machines which are no longer usable. Now, in the stage of recover, what they will do is, and you might have seen this also, that any product like this one, phone or printed circuit board, they have some precious metals in them. For example, the contacts could be made of precious metals like gold or silver or some similar metal. Now, what they will do is they will put it in a process by which they can extract those which are valuable, and then they will discard whatever is not valuable. And again, you might have seen what people do. And this video or last video I also saw was also from Pakistan, where they are taking printed circuit boards and then they are using means to extract the gold out of that. And at the end of the video, they will also show the weight of the gold. Sometimes they will also show old switchboards, means the switches, electric switches that we use in our houses. Now, because conductivity of silver is better, it has a small amount of silver in it. Now, what they do is, in a building, maybe the entire light wiring has been changed, so they have so many switches available. They will extract the silver out of that, and they might be able to extract maybe 2 or 3 kilos because they have so much of waste material to do it from. But what is happening is, in this recovery process, several times it is possible that they are using up a lot of energy. They are creating a lot of toxic waste and a lot of toxic fumes. So in the last video that I saw, where people were recovering gold from printed circuit boards, they were actually melting down the circuit boards. In melting down the circuit boards, a lot of toxic waste is produced and a lot of fumes are produced and a lot of energy is consumed. All of this is waste. So what I'm trying to say is that although it is a strategy, but it should be the least preferred one, because you are trying to take out resources from your waste, but there's a cost involved here. So it's not always that all of these strategies are good for us. Just keep that in mind. And of course, had it been a linear process, none of these are strategies, then that our approach would have been that our waste product will actually go into either landfill or we just burn it up. This is what we do. So the outcome of this landfill or incineration is environmental pollution. The outcome of R8 and R9 strategies is at least you are taking waste out and you are converting it into or part of it into a resource. The outcome of R3 to R7 strategies is that you are preserving and extending the life of products. And the outcome of R0, R1 and R2 strategies is that we are going towards responsible use and manufacturing. So as we are developing into a circular economy, we have to go into the design phase and design products and services and processes in such a way that the circularity is built into the design of the product itself. So to sum up, these R0 to R9 strategies, which are simply referred to as the R strategies, they are aimed to get the maximum out of circular design and manufacturing so that we are able to keep resources in use and not put them out as waste. So these strategies are categorized on the basis of the loop that has to be run: short loop, medium loop, and long loop. So R0, R1, and R2 are the shortest loops. R3 to R7 are medium loops, and R8 and R9 are the long loops. Naturally, the shorter the loop, the more sustainable your strategy is. So just to repeat, we need to think of short loop business strategies. We need to come up with business strategies that have short loops like R0, R1, and R2. Of course, those strategies which are based on shorter loops are less dependent on resources and therefore they are more circular. The waste generated is also less. So if we talk in terms of value chain, then at the highest level of the value chain are the shorter loops, and larger loops go down towards the lower level of the value chain. So we have already discussed this. Short loops are R0, R1, R2. Medium loops are R3 all the way to R7. And long loops are R8 and R9. Let's move on from this. Let's see if anyone has actually put this into use. किसी ने ऐसा किया भी है कि नहीं कि हम सिर्फ बात कर रहे हैं. So, for example, collecting old electronics, extracting valuable components, using them in new products. ऐसा कौन कर रहा है? all of us have heard this name. मेरे सामने दो प्रोडक्ट्स रखे हैं, HP के तीन प्रोडक्ट्स रखे हैं, एक प्रिंटर है, एक लैपटॉप है, एक पीसी है. So all of us know HP. Its own claim is that it wants to be the world's most sustainable and just technology company. They have made a commitment that they will reach 75% circularity, not just in their product, but also the packaging of that product by 2030. They will reduce the value chain greenhouse gas emissions by 50% in the next 5 years, and they will achieve net zero by 2040. So naturally, it cannot be done overnight. This company has made a timeline, it has committed, and it is trying to achieve that. Similarly, in this country also, we have made timelines like this. I will come to that aspect. So what they are doing is they have aligned all the processes like design, the output of the product and the solutions, their logistics, which means movement from company to customer and back, manufacturing, financing, etc., etc. All of it is aimed towards meeting this goal. HP is not the only one. I'm just giving some examples. All of us, because I gave the example of photocopiers, so I have also brought the example of Ricoh. Ricoh is a major company. It's a Japanese company in imaging and electronics. It uses a unique sorting process whereby what they do is they will get back their own photocopiers and their own printing machines, and they will evaluate, and based on this they will decide how they are going to reuse them. They may remanufacture them, they may refurbish them, they may disassemble them and take out some of the useful components depending on the condition of the product. So this is Ricoh. Moving forward. Now, interestingly enough, the world has always been dependent on fibers like jute, cotton, etc., etc., and then synthetic fibers. Now, interesting thing is that most fibers, particularly natural fibers, have the capacity to be brought back into reusable condition many times. So this is very interesting. And therefore, this company that we all know about, Levi's, it joined with another company which is called Evernew, EVRNU, Evernew. What they do is they are developing, in fact, they have developed a product which uses used cotton clothes into high quality jeans. So they will collect old cotton clothes which have been used, and they will use them to make jeans, not just ordinary jeans, but high quality jeans. So they are recycling the cotton fiber from there. So they are converting used cotton into high quality denim like material. Another company is called Pure Waste. Its clothing is made not just of 50 or 60%, but 100% recycled fibers, of which 60% is cotton. And I talked about plastic glasses. Now they will extract polyester from items like plastic glasses and bottles. 40% of their product is made of polyester, and the rest is made of cotton. And remember, in many countries, in India, of course, like where we live in the north part of India, where I live, the weather is not very good if unless I'm wearing cotton. So we prefer cotton, but in many parts of the world, the weather is perfectly fine to wear blended cloth. So you have polyester plus cotton blended garments available there. Now let's see what it does. So company itself says that when they make one t-shirt out of recycled materials, then they need 1.2 liters of water, and they generate 1.1 kg of carbon. Same thing if they are doing using absolutely fresh materials, so virgin materials, then they will use 1426 liters. So more than 1000 times much water, and it will produce another 1 kg of carbon dioxide. So they say that till 2022, end of 2022, the fact that they were using used fibers they had saved so many billion liters of water and so many million kilograms of carbon dioxide, more than 4 billion, close to 5 billion liters of water and 3 million kg of carbon dioxide emissions. That is a lot just for one company. Similarly, if we are talking about design, then we can also think about why do all of us need to buy so many clothes. If I look at my own almirah, sometimes I feel ashamed because I know that I don't have space to store more clothes and still I'm buying more clothes. And then there are people who do not have sufficient clothes. So naturally, I am putting a extra demand for resources for producing those garments. So why don't we rent those? Is it possible to subscribe to some garments? If I need to wear a suit for a party, why do I have to buy that suit? Can I not rent that suit? This is the idea here. So by doing this, we will reduce the environmental footprint and we will reduce the need for producing new garments all the time. So businesses, these are already very much in operation. There's one company called Rent the Runway. Another one is called Litote. They offer subscription-based services that will allow consumers to rent garments or apparel for a set period and then return it. So this gives you flexibility, it gives you convenience, it might be even more cost effective, and you have the ability to match up the fashions also. So many people using the same garments. Similarly, there are companies which have initiated reuse programs for their packaging and other materials. In India itself, Tata Motors is one of the largest producers of heavy commercial vehicles in India. It realized that in India, the unique thing is that when they sell a truck, normally trucks are sold in the chassis form. And we have a bodybuilding industry, which essentially means that the body of the truck is built by some bodybuilder outside. Now they realize that because when they send the chassis, the truck has to be driven out, so they had to install a driver's seat. And when the owner of the truck got the body built upon the chassis of the truck, what they would do was they would remove that seat and install a fresh seat. So that seat which had been installed by the company used to go waste. So what Tata Motors did was they started a program by which they would pay for sending back the seats. And by doing this, they did not have to invest in so many new seats because they were getting relatively new seats back from the bodybuilders. And by doing that, one of the materials was being recycled. So similarly, packaging materials. Now, I think you would have seen that if you're ordering from an e-commerce site, typically you will have a lot of packaging material, but printed on that, you will find that this is 100% recycled material or it is 100% recyclable. You buy a pair of shoes, the same thing is written on the box of shoes. So this is important thing is because so much of packaging material is used, that also has to be circular. So reusing packaging materials is important. And there's a company which offers a dedicated service for this. It's called TerraCycle. It has partnered with brands like Procter & Gamble, Henkel, Office Depot, Suez, etc. What it does is it helps them to recycle the packaging material that they are using. And it is also through its research and development efforts, it is coming up with the strategies on how to recycle those products which are difficult to recycle. Now, TerraCycle is already present in more than 20 countries, and it has a product called Zero Waste Boxes. Zero Waste Boxes are packaging boxes which are based on packaging recycling of various types of materials. So like I said, Tata Motors used innovative strategies for the driver seats of newly shipped commercial vehicles. So these are some good examples of how companies have already adopted a certain level of circularity in their businesses. Now let's move on to the second part of this discussion, which involves biogas production. And I know that all of us are aware, we are very familiar with what is biogas, But how many of us have heard of Satat? SATAT. Just quickly, if you can just raise your hands, how many people have heard of this scheme? Right. So just to showcase what is happening in our own country in terms of circularity. Acha, okay, so we have 2 hands. Right, just in the interest of time, I will go into it briefly. Now, SATAT is an acronym for Sustainable Alternative Towards Affordable Transportation Scheme. This is SATAT. And SATAT, one of the aspects of SATAT is the production and blending of compressed biogas. So this biogas, which we've all seen in various forms being used, like for example, we use it in our laboratories to as a gas to burn for heating. But biogas can be used for cooking, it can be used for so many things, and then it can in the compressed form, it can actually be used as a fuel for automobiles. So SATAT is, because it deals with transportation, it wants to boost, or it aims to boost the production of compressed biogas. It was launched in 2018 just for this purpose, because naturally biogas is a clean fuel. It will not have the kind of emissions that our conventional fuels like petrol or diesel will have. And therefore, the government aims to establish an ecosystem for the production of biogas from waste and biomass for use in transport. Now remember, the problem statement is very simple. We have all seen, okay, any more raised hands? Just 1 minute, please. Fine. So all of us have seen that the globe is dependent on conventional fuels, so which is particularly petroleum, so oil and natural gas, and God Almighty has been very kind to India in so many aspects, but we do not have so much of reserves of petroleum, and therefore we are dependent on imports of petroleum. In fact, petroleum happens to be the largest item on our import bill. And we also know that petroleum is not just an economic resource, but it's also a center of geopolitics. We just saw what happened with Venezuela. So and it's a limited resource. It is a non-renewable resource. So it makes sense to reduce our dependence, especially as a country like India. It makes sense to reduce our dependence on petroleum products. And for that objective, we have been trying for substitute products. So with that perspective, one of the important things about things like biogas or even other biofuels is that they are important import substitutes. They are strategically important for our country. The second thing is that in India, we are, like I said, we are very, very well endowed with so many resources. We have a lot of arable land. So much of our population is involved in agriculture as a primary source of income. So we have a lot of agricultural resources available to us, particularly agricultural waste. We also have a lot of livestock, which produces waste, which can be converted into biogas. So the raw material for biogas is available in our country. So we have a problem and we have a possible solution. And this conversion of biomaterials into fuels is one of the solutions. So this is exactly what is written here, that traditionally the nation has had vast agricultural as well as livestock resources, And we also have a rising energy demand. We are a growing economy. We are also a growing country. We will always have growing requirements for energy. So we need to shift towards alternate energy sources like solar, like wind, tidal, so renewable energy sources, even hydroelectric, nuclear energy. But in that entire portfolio of energy sources, biofuels and biogas are important. So we through very outstanding schemes like Ujjwala scheme, we have reduced the dependence of households on biomass as a mode of cooking and even heating. So we have had conventionally the biomass and things which are used to produce biogas, they have been used for cooking. But now compressed biogas is being used as a transport fuel, and projections show that the market is going to expand rapidly, and there is a lot of investment which is already has been made, and there's a lot of investment which is in the pipeline for developing this resource, which is compressed biogas. It takes time to develop. So currently our capacity is in the initial stage of development, but there's huge potential for the use of biogas for transportation, for industrial use and other uses. There are massive untapped opportunities both in rural and industrial sectors. I'll just share some statistics with you in the next slide, having built up this background. Now, the government aims through various schemes, including Satat, that there will be more and more focus on bio-CNG for transportation as well as for industrial adoption. This will reduce our carbon emissions. There will be more plants which will be producing biogas. And one of the things is that there's a lot of research and development also going on. And one of the challenges in getting gas out of biomass used to be how to convert it from one to the other form. Now we have developed technologies which will allow us to do anaerobic digestion better. So doing that will enable the producers to be able to generate more biogas out of biomass. And there are some industries which produce a certain amount of waste, and that waste can be used again for generating energy. So particularly textile industry, food processing industry, which generate waste, can use those wastes, convert it into biomass and use it for their energy requirements. As of now, there are more than 3 states, but the states which are at the top 3 in this trend of using biogas and setting up biogas plants are Maharashtra, Gujarat and UP, because they have strong agricultural bases and also because they have populations. That could be one of the reasons, but they have the will also that they are doing this. Now remember, biogas market in the next 5 years is going to grow very fast. Market's size forecast will be reaching billions by the early 2030s, and the annual growth rate, compounded annual growth rate, is also going to be high. I'll just show you the exact statistics. But apart from this, what will happen is that it will also generate a lot of employment opportunities, especially in rural areas, because biogas production process itself is labor intensive, and we are a labor surplus market. So we will have a number of people to whom this technology will offer employment opportunities. And therefore, it is safe to conclude that in the near future, there will be more and more shift towards upgradation of biogas to compressed biogas. So that's a more valuable form of biogas, so that it can be used in vehicles, in industries, and this will emerge as a major growth area. Important thing is it will reduce our dependence on the fossil fuels such as petroleum. Now coming to the numbers. There is a particular report, and at the end of this presentation, I have put a reference also. So I have cited this, given the entire reference. So anyone who is interested can just click on that link and see this entire report. This report, the title is India Biogas Market Size, Share and Industry Analysis by Feedstock, which is organic residue and waste, including animal waste, municipal waste, sewage, agricultural waste and others, and energy crops. So energy crops like Jatropha. By application, which means what is the end use of that? Heating, electricity generation and transportation. So 3 areas where it can be used: generating power, heating, and for transportation. And country forecast.
Hello, am I audible?
Yes, sir.
Uh,
Yes, sir.
sir, okay. हेलो, शायद सर अभी अवेलेबल नहीं है ना सर, शायद वो हो गए सर की ऑडियो। आपको लोगों को आ रही है क्या आवाज सर की?
यस सर,
No,
आवाज आ
sir.
रही है सर।
हेलो,
नहीं आ रही है सर।
सर
नहीं आ रही
तनुज
है?
सर की नहीं आ रही है।
ओके, आई विल कनेक्ट टू रिसोर्स पर्सन।
सर उनका माइक ऑफ है, तनुज सर का।
माइक ऑफ।
Tanuj sir, your mic is
तनुज
off.
सर, your mic is off.
Yeah, so I was saying, I'm sorry, participants, that I got disconnected. I didn't even realize that. Some internet issue. So can someone help me out by telling me where I was? So I'll just start from there. इस स्लाइड तक पहुंचे थे हम लोग.
We're talking about numbers.
Okay, so I'll start with the numbers, right? वहीं से मैं शुरू कर देता हूँ.
Okay, sir.
Okay, so the numbers, and in case you missed it, I'll just mention that there is this report. It's an interesting report, and I have cited this here, and at the end of this presentation, I have put the reference for that. So you can click on that or copy and paste, and if you're interested, you can see the detailed report of this. Now, this report says that the value of the Indian biogas market is, in 2024, it was 1.64 billion, but by 2032, it will be more than double of that. which means that the compound annual growth rate in this period is going to be in double digits, 10.2%. That's a lot. And this means that there's a huge amount of potential for biogas in India. There are more than 5 million biogas plants operational in this country, of which 3 states I already mentioned. But apart from that, we also have Karnataka and Madhya Pradesh, which are the major states in the biogas production. Also, the report says that the amount of production that we can do, energy production that we can do using biogas, compressed biogas, is enough to meet more than 9% of India's energy demand. That's a huge amount. Any one source which can meet so much of India's energy demand is very, very valuable. So 9% is a huge number. Right now, of course, the output is less. It is 3.2 billion cubic meters per year, but it can go all the way to 62. And this is likely to be achieved in another 23-24 years. And this is the link for this particular report. Let's move forward. So in a visual, just to visualize this is what the report says. And you can see by 2032, the market is going to double what it is right now, more than double. The output is going to more than double. Let's move from biogas to biomass. So trends in biomass production and use in India. Again, biomass has traditionally been used for domestic applications such as heating and cooking. Biomass is the sum total of all the naturally produced resources, including leaf litter, so leaves, animal waste, etc. All of that contributes to biomass. But now we are shifting towards power generation, and this is being actively pursued by the Government of India through schemes promoted by the Ministry of New and Renewable Energy, that is MNRE. So the name itself is New and Renewable Energy. And also, one of the reasons for this is not just to generate energy, but also to actively manage the waste that we are generating. At the beginning of this today's session, I mentioned that we are not very good in managing our solid waste. Most of it is going up and polluting our environment. So that's an important active problem which is facing us right now. Now, what we are doing is we are not dependent on biomass only for domestic consumption. We are converting them into pellets and briquettes, which can be used for firing or as an additional energy source in thermal power plants. So it is being burned for producing energy. And the other use is to convert that biomass into biofuels, because we have a large amount of agricultural residues like bagasse, husk from rice, and so many other agricultural products. What it will allow us to do is it will allow us to develop sustainability and generate solutions which we call waste to energy solutions. So we start with waste and convert it into usable energy. So this is what we are trying to do in biomass production. And biofuels. Now, all of us are familiar with biofuels. We know that today the fuel that we are buying from the petrol pump or even diesel is blended with ethanol, which is biologically generated. So, and we know that now the target has been, like in 2025, the target became 20% blending. So that means 20% of the fuel that we are buying is ethanol blended, it contains 20% ethanol. So what it does is that any crop waste, even grass, can be converted into renewable fuel through bioremediation, etc. So, as I mentioned, there's a lot of technology and research and development that goes into this, but through this process of pre-treatment, hydrolysis, fermentation, we convert agricultural waste into ethanol. Then this is distilled, and what they do is they generate ethanol, and then that ethanol can be used as an alternative or as a blend to fossil fuels. So currently we are using it for blending. Now, as we discussed earlier, the problem statement is very simple. There are multiple uses because one thing is our fossil fuels are non-renewable. Second thing is we are generating a lot of waste, which can be utilized if we are converting it into ethanol. Third thing is that then we are moving from a non-renewable energy source to a renewable energy source. And most important thing is that we are becoming less dependent upon imported fuels. So for this reason, our country is focusing on rapid expansion of biofuel production. There is an initiative called the National Policy on Biofuels, NPB. Now, the targets that it has set is 20% ethanol blending in petrol by 2025, 5% biodiesel blending by 2025. Initially, the goal was 2030. Now they have moved it backwards, which means they have done this earlier. So earlier it was to be achieved by 2030. Now they are doing it now. So maybe we are not even aware of this, or we have not read about this, but we have become the world's third largest ethanol producer. This is because the same things, our national policy on biofuels is one of them. There's the ethanol blending program. This will boost our energy security. So we'll not be so dependent on other countries for our energy requirements. It will reduce imports. It will also support farmers because then even their agricultural waste will have a price associated or a value associated with it. So it will boost their incomes, and it will use sugarcane, food grains, and their byproducts, waste products. It will use them. It will add value to them. So this actually is an example of circularity. So needless to say, the benefits are very, very vast. Energy security, economic growth, rural income will go up, and importantly, it will promote circular economy because biofuels will produce much less of emissions. They are much cleaner burning fuels. Now remember, in India, we have currently blended to 20%, but because of technology, because of research and development, automobiles today can run even on 85% to even 100% biofuels. In Brazil, they are already permitting 100% biofuel operated vehicles. And that fuel is also available in the market now, 100% biofuel. So there's a long way we can go, and which is very positive for a country like us. And on that positive note, what I will do is I will stop from my side, and I will this is what we have covered today. These are some references and suggested readings, which I will leave with you, but I will open it for your comments and questions, if any. Anything to comment, किसी को कुछ बोलना है, कुछ ऐड करना है, कुछ डिस्कस करना है, या anyone has any questions, you are more than welcome to discuss here.
Nothing, sir. Thank you.
Right. So thank you all so much. These are
Thank you so much, sir.
the suggested readings. So from my side, thank you so much.
Thank you,
So,
sir.
as we come to the concluding part of this session of our FTP, it is my proud and privilege to thank our esteemed resource person, Dr. Tanuj Nandar sir, for delivering such an insightful, thought-provoking, and inspiring session. Sir, your insightful explanation of circular business concept and real-world examples and emphasis on sustainability and economic transformation have added immense value to this faculty development program. The session was both thought provoking and practically relevant. We sincerely thank you for sharing your expertise, valuable time, and knowledge with us, which was truly enriched which has truly enriched our learning experiences. Thank you so much, sir.
Thank you all. It has been a wonderful time for me. Thank you.
Thank you so much, sir. Once again, sir. Thank you so much, sir, for being with us, sir.
Okay. Right. I hope to meet all of you soon.
Yes, sir. Yes, sir. Thank you, sir.
Thank you, sir.
Okay. So good night to all.
Thank you, sir.
Good parties.
Night, sir.
Thank you, sir.
Okay.
Thank you, sir. Thank you.
Welcome to it.